Let's look at an example that is nonlinear, meaning it's not in the form of y equals mx plus b. Instead, we're going to look at a function, simply f of x equals x squared. So this is obviously a polynomial, but how does this affect the formal definition of a limit? So we're going to look at the formal definition of a limit and see how this plays out. Now remember, in the formal definition of a limit, we have to do some scratch work, or what I call some think work. We got to realize that epsilon will always be greater than 0, and then you're trying to investigate what delta you should use. And then the way you do this is you analyze the absolute value of f of x minus L. We want to know the distance between f of x and L. What would happen if we try to simplify this? Notice you get a difference of 2 squares, so you're going to factor. And you get the x minus a that you're looking for, which is x minus 2. Now we are going to make a very bold assumption here. We're going to go ahead and suppose the absolute value of x minus 2, that distance is relatively small. Well, what's a good choice for a small number? Well, in this case, we're going to choose 1. If we choose 1, we know this inequality will break up into this inequality. And this will lead to your other inequality, which is 1 is less than x, which is less than 3. Now, if x is less than 3, what happens to the absolute value of x plus 2? Well, this becomes strictly less than 5. And so let me draw a squiggly line here. Now we know this is strictly less than 5. 5 times something. Well, ultimately, we know that the absolute value of x minus 2 is less than 1, but we also need it to be less than something else. So that something else is the same technique that we used before. 5 times what will get me epsilon? That's what you're going to ask yourself. 5 times what will get me epsilon? Well, what we want to do is make sure that the absolute value of x minus 2 is also less than epsilon over 5. That way, when you multiply these two quantities together, you will indeed get epsilon. So it's a little tricky. We need absolute value of x minus 2 to be less than 1, and the absolute value of x minus 2 to be less than epsilon over 5. So this requires us to have a delta that is a little bit more sophisticated. In fact, we're going to say let delta be the minimum of those two numbers. So we want delta to be the minimum of 1 and epsilon over 5. And we'll go ahead and write the formal proof using this delta. So the second process is writing this formal proof using some of your scratch work and your think work. The first sentence is that is given epsilon to be greater than 0. We're going to state our delta now. And now we're going to have cases. Case 1. If delta is equal to 1, then we're going to go ahead and observe this part here. Now, not only is it less than 1, it's also 1 is going to be less than or equal to epsilon over 5. Once you establish that, we're going to go ahead and simplify the distance between f of x and L. we know the absolute value of x plus 2, because delta is equal to 1, we know that the absolute value of x plus 2 will be less than 5. We also established that the absolute value of x minus 2 is less than 1, but 1 is less than or equal to epsilon over 5. This part is already strictly less than 5, so we don't need the equal sign here on the next step. Absolute value of x minus 2 would be at most epsilon over 5. And multiplying these two numbers together, you indeed get epsilon. So that ends case 1. Now case 2 is very similar. It's just a little bit easier to read. If delta is equal to epsilon over 5, then we have 0 is less than absolute value of x minus 2, which is less than epsilon over 5. Turns out we don't need this second inequality. We simply just need this part here. And that's what I mean by simply easier to read for case 2. I'm going to simplify the distance between f of x and L, which is the absolute value of f of x minus L. And notice the algebra is very, very similar, except this time the steps are even easier to read. And the reason why we know the absolute value of x plus 2 is less than 5 is because the absolute value of x minus 2 is also less than 1. You know, it's less than 1 here. Even at most, it could be 1 if these two numbers were the same. You know, this could be 1. But we already know this one is strictly less than epsilon over 5. So even if this was equal to 5, this will still be less than. Multiply those two quantities together, 5 times epsilon over 5 will get you epsilon. So in either case, the distance between f of x and L is going to be less than epsilon. That allows us to make a conclusion. That allows us to make the conclusion that the limit does exist. Not only does the limit as x approaches 2 from both sides exist, but the limit of x as x approaches 2 from both sides of x squared is going to exist as the number 4. And that concludes the proof. You can see how different a nonlinear function will contribute different procedures and different sentences in the formal definition of a limit. Now remember, your scratch work is very, very important, so I'm going to go ahead and encapsulate that, realize that that is very necessary, and then you also have to realize that the final answer to this example is actually all the sentences in the proof in that specific order with those very, very specific details, and make sure you put your periods in the right spot. I'm missing a period here, right there. Hope you guys can see that. Make sure you have your periods to indicate your sentences in the correct order. And that order really, really does matter.